Hello my dear students, welcome to IMS Gate Academy. Myself Sandeep Padari. In this video, I would like to cover the technical aspects of Burj Khalifa and how the civil engineer has applied his applications. Before going into the technical aspects of Burj Khalifa, what we do at IMS Gate Academy. We at IMS Gate Academy provides you the offline gate coaching, online gate coaching, self-recorded sessions. And remember my dear students, we are giving you the GATE question booklet which covers 34 years of previous year questions. In this, we are providing you the alternative solutions, key pointers, and for the difficult level questions, we are providing the QR code where you can scan it and observe the video. And remember, my dear students, we at IMS Gate Academy have subject-wise material, exercise book which covers level 1, level 2, level 3 questions. In this, we also cover the variety of questions like NAT, MSQ and MCQs. And remember my dear students, at every juncture, you have to test yourself. So we have come up with the tests, that is chapter-wise test, subject-wise test, advanced level test, multiple subject test and all India mock test which will be replica of the GATE exam. And remember, we are providing around 130 plus tests. And the key success for GATE is the one-to-one mentorship. We are providing you the one-to-one mentorship where the weakness can be converted into strength. We identify the student's strength and weakness. We will train him the entire roadmap for that entire year. Apart from this, we are also providing the doubt solving portal where the solution will be provided within 24 hours of time. And remember my dear students, if you are interested to watch for these kind of videos or if you want to have any job notification updates, you can join our Telegram group. And remember my dear students, you can like and share our channel. And coming to the structural design of Burj Khalifa. Now my dear students, if you see, what is the beauty of Burj Khalifa is, it has a height of around 830 meters. Imagine the height. If the height is 830 meters, how slender, if the member is very slender, they are very easy to bend. So due to the very wind storms, Dubai is like it's a place near to the seashore. So in that areas, there will be a lot of winds and there are a lot of chances of bending or swaying. So how can you overcome this is, we have come up with the hexagonal core. Hexagonal core is a core which we are providing like a shear core or a shear wall. What happens in a shear wall or a shear core is, my dear students, like whenever there are winds or anything, like 30% of the wind safety will be taken by shear walls, which you see in multi-story building by providing the lifts. But here, hexagonal core will take almost 60% of the wind. And remember, this hexagonal core is entirely made up of RCC and this will also help to balance the weight. So in this area, by providing this core, how this area is utilized, let me tell you, it has a height of 830 meters and in these areas we have the fast moving like elevators, fast moving lifts. And see students, the innovative of this made them to utilize that core area for the lifting and you can say innovative design where the core facilitates efficient vertical transport because it should be fast also. Now coming to the structural analysis part. See my dear students, as I told you, you are talking about the slenderness. Now one innovation came from the designer, like his innovation came from in a dams, if you have a wall, you will be providing the buttress. So they have collected the idea from there and they have implemented the buttress. Okay. So by providing the buttress, see students, what happened is they are trying to support the entire core. And by providing the buttress, the space is also utilized for corridors and they've utilized the space also in a more and an efficient way. So if you see the stepped design, buttress of future is a stepped shape design to accommodate the practicality of vertical towers around them. So this will also help to make the structure stable. Now coming to how to resist the tensile stresses. Now my dear students, as you are aware, concrete is very weak in tension. But by providing the steel in the core, some tensile stresses are improved. But how these tensile stresses can be resisted? Let us think. If you see the basic agenda, See, my dear students, if you see binding stress is equal to moment upon section modulus, by providing more section modulus, we can reduce the bending stress. So they have come up with a section shape, I shape. Why? Because I-shaped sections will have more section modulus. By that, the bending stress will be reduced. So my dear students, we should appreciate how the design has came into picture by the designer. Now, see what is the shape here? Now coming to the shape here, the shape is asymetrically stepped. So usually we are habituated for symmetrically. By why they are asymetrically stepped means there is a concept called vortex shedding. Means it is a concept where the building can sway here and there. And if you see, asymmetrical design has came and this made to overcome the vortex shedding. Because of vortex shedding, resonance will happen. See students, wind induced vortices create fluctuating forces that can be lead to dangerous vibrations, potentially causing structural collapse or resonance occurs. To avoid this, they have come up with the asymptotically stepped. Now, my dear students, the core support, if you see, as I told you, the core support 70% is made up of RCC and the remaining top portion 30% is taken care of steel. And remember, in the top portion, they also take care of the lightning by the principles of with the help of the electrical engineers. They have taken care of the lightning also. And the upper portion can swing up to 6 meters, my dear student. And let me tell you one important thing. This Burj Khalifa is built in Dubai, where it is a very loose sand. So what they have done is, they have almost went 140 meter deep into the soil and they try to build the raft foundation. Still, if they feel that it won't be sufficient, then they have provided the piles, and top of it, they have provided the raft foundation. And remember, my dear students, by providing the raft foundation, they have taken care of the differential settlement. And these are the main technical aspects what comes under Burj Khalifa design. I hope in this video you will get an idea what are the technical aspects of Burj Khalifa. Thank you and all the best.